Alright, given f of x is equal to x squared plus 2x minus 3, and g of x is x plus 5, determine the intervals of increase and decrease of h of x in each case if h of x is equal to f of x times g of x. Okay, so first let's figure out what h of x is. So h of x here is f of x, which is x squared plus 2x minus 3 times g of x, which is x plus 5. If you want to find the intervals of increase and decrease, let's first find some critical numbers. So to find critical numbers, I need to let h prime of x, or the derivative function of h of x, equal 0. To define h prime of x, I'm going to find the derivative by using the product rule. So I'm going to do derivative of the right, x squared plus 2x minus 3 times x plus 5 plus the derivative of the left, the right factor now. I think I mixed it up when I was talking earlier, but derivative of x plus 5 times x squared plus 2x minus 3. Okay, so first do derivative left times the right factor plus the derivative of the right times the left factor. Now you can reverse the order if you want, because multiplication is commutative. So in this case you get 2x plus 2 times x plus 5 plus derivative of x plus 5 is 1, x squared plus 2x minus 3. So this is your h prime of x function. And then what I want to do is expand this guy out. Okay, so if I expand this out, I'm going to FOIL it. You get 2x squared plus 10x plus 2x plus 10 plus x squared plus 2x minus 3. Okay, so then what I want to do here is I'm going to get 2x squared plus x squared plus 12x plus 2x, that's 14x, plus 10 minus 3 is plus 7. So that's 3x plus 14x plus 7. Okay, so this is h prime of x. Okay, we're going to ask ourselves, okay, this basically looks like a quadratic. Is this factorable? So we need to write down a, b, and c. A here is 3, b here is 14, c here is 7, ac here is 21. Two numbers that multiply 21 that add up to 14. Not possible, because the only two numbers that evenly multiply 21 is 3 and 7, or negative 3 and 7, which will not in this case add up to 14, right? So if we want to actually let h prime of x equal 0 and solve for x, we're going to have to utilize the quadratic formula. So we get 3x squared plus 14x plus 7 is equal to 0. And recall that the quadratic formula here, x is equal to negative b plus minus the b squared minus 4ac over 2a. Okay, so I'm just going to kind of do this a little bit quickly. Okay, so I'm just going to move this up here. But in this case, if I plug it in for the quadratic formula, negative b is negative 14 plus minus b squared is basically 14 squared minus 4 times 3 times 7 over, right, 2a. So 2 times 3, and I'm just going to crunch that out. So this gave me negative 14 plus minus 112 over 6. Okay, now what I want to do is I want to create decimal values just so I can kind of perceive these intervals a lot better, right? So you need to look at the positive and negative values. I'm just going to round this to 3 decimal places. So those values are going to be negative 0.569 and negative 4.097. Okay, so those are my two critical points. So basically using my two critical points, okay, so I'm just going to put, so let's say 0 is here, this is positive infinity, right? And let's say that this guy here, and I'm drawing this on an arbitrary scale, let's say that this point here is negative 0.569, and this point here is negative 4.097, this is negative infinity. So you're basically going to look at 3 intervals, right? So this interval here is negative infinity and negative 4.097. This interval here is between negative 0.569 and 0. Oh, sorry about that. didn't see that there was a, should be looking at this interval. Okay, so this interval here is negative 4.097 and negative 0.569. And the third interval is going to be out here. Okay, and this interval here is negative 0.569 and positive infinity. Okay, so now we have 3 intervals. We want to test to see these intervals. I'm going to use a different color just to kind of highlight this a bit better, right? I know it's a little messy. Maybe we can get some space out of this. Okay, so let's test each interval. So I'm just going to kind of separate each interval. So let's take a look at this interval between negative infinity and negative 4.097. I'm just going to test the value. Let's do x is equal to negative 5 because it falls in this interval. So I'm going to do h prime of negative 5 into my function, and that's going to give me, this is going to give me 12. Okay, so because we know that h prime of negative 5 is greater than 0, then this is an interval of increase, right? Because it's h prime of x is greater than 0, it's an interval of increase. Then what I want to do here is I'm going to test this interval. It's between negative 4.097 and negative 0.569. Okay, so to test that interval, I'm going to let x equal something between these two numbers. Let's do negative 2. Okay, let's do h prime of negative 2. And if I plug this into my derivative function here, let's see what I get. Get negative 9. So this tells you that it's an interval of decrease. It's an interval of decrease because h prime of x is less than 0. Okay, and the last interval between negative 4.0, negative 0.569, and positive infinity, looking at this interval here, right? Let's say x is equal to, and you can literally plug in any number. Let's do 0 because it's just a lot easier, right? And you can see that h prime of 0 here is equal to 7. So this tells us that this is an interval of increase. Okay, so because h prime of x is greater than 0. Okay, so those are our intervals of increase and intervals of decrease and interval of increase as shown. Okay, so collectively, if you wanted to write this, right, an interval of increase will occur between negative infinity and negative 4.097. It will also occur between negative 0.569 and positive infinity, and an interval of decrease will occur between negative 4.0